Hey guys, Mr. B here. In this video we're going to be going over the answers for the questions in the chapter 26.1 notes. So if you have any confusion on some of the questions, hopefully this will help clear it up for you. So, alright, let's take a look at number 1. It says the sun gives off a large amount of energy in the form of blank radiation. This would be called electromagnetic radiation. It's a very fancy way of saying light, which is basically what light is. It's just radiation. Number 2, circle the letter of each sentence that is true about nuclear fusion in the sun. Less massive nuclei combined into more massive nuclei. That is true. So we're going to turn that red. The end product of fusion is hydrogen. That is false. The end product is helium. Fusion is a type of chemical reaction. It is not. It is a type of nuclear reaction. And then hydrogen nuclei fuse into helium nuclei. That is true. Okay. So those are the two true statements there. All right. Number 3. For the sun to be stable, inward and outward pressure forces within it must be in. The word here we're looking for is equilibrium, which is basically a fancy way of saying balanced or in balance with each other. So the outward pressure of nuclear fusion or thermal pressure from like the fusion happening, the sun's constantly trying to explode all the time, has to be balanced out by gravity, which is constantly trying to crush the sun. So the sun's constantly trying to explode all the time and gravity's trying to crush the sun all the time. Those two forces have to be balanced out or equal. Otherwise, one of two things will happen. Either the sun would explode or the sun would get crushed down into a tiny little ball from gravity, right? So if those two forces weren't balanced out, the sun would do one of those two things, but it doesn't. So clearly those forces are balanced out. So number 4, true or false? The sun remains stable because the inward pull of gravity balances the outward push of thermal pressure from nuclear fusion. Exactly what we were just talking about. That is true. Okay, those two forces are balanced out, which means the sun remains stable and it stays the same size pretty much all the time. All right, number 5, circle the letter of each layer of the sun's interior. All right, so there are multiple layers in the inside part of the sun, and then there's layers on the outside. The inside layers we have the radiation zone, so that is one layer. The convection zone, that is another layer. The photosphere is not one of the interior layers, that's one of the exterior layers, so not the photosphere. And then the core, of course, is the very furthest inside the sun. So those are the 3 layers here that would be inside the sun. Number 6, circle the letter of each way that energy moves through the sun. All right, so energy is created in the core, but it has to move its way out through the sun to the outside so that it can essentially escape and go out as like sunshine. And there's 2 ways that it does this. One is convection, letter B. Okay, convection is where that's where heat rises. So heat goes from the inside of the sun and it rises up to the surface through the convection zone. Okay, that's convection. And then letter C, radiation, is the other way that energy moves throughout the sun. Radiation is in the radiation zone. That is where energy is, it gets released, and then particles absorb that radiation, and then, or they absorb that energy, and then they release it again. And when they release it, that's what we call radiation. So they release the energy, and then it gets absorbed again, and then that one releases it, so it radiates it, and then it gets absorbed again. And it does this over and over and over as it works its way through the radiation zone over a very long time, until eventually it gets to the convection zone, and then it rises to the surface as heat, and then eventually it gets to the surface, and then it leaves the sun to travel through space. Nuclear fusion is not a way that energy moves through the sun. That's how energy is produced. So that is not an answer that we are looking for, because we're only talking about how it moves through the sun. All right, number 7, circle the letter of each layer of the sun's atmosphere. So the atmosphere are the outer layers of the sun. The photosphere is one of them. That is considered the surface. The easiest way to remember it is like if you were to take a picture or a photo of the sun, and you were to look at it, the layer you would be looking at or seeing is the photosphere. The other layers are very thin, and the photosphere outshines them, so you can't see them unless there's like a solar eclipse going on or something. The chromosphere is another layer of the outside part of the sun or the atmosphere. It's very thin. Again, you can't see it unless there's a solar eclipse going on. And then the corona also is the furthest outer layer of the sun. And again, you cannot see that one either unless there's a solar eclipse going on. We know that the core, of course, is an interior layer not on the outside. So number 8, when can the corona be seen? We just mentioned this. So the corona can only be seen during a solar eclipse. If you've ever seen a picture of a solar eclipse, there's a very thin, wispy kind of thing radiating out from the sun. That's the corona. And in fact, we can even bring up a picture here. So solar eclipse, just to see it. Let's look at some images. So if we look at like this picture here, you can see there's kind of these like, you know, like streaks coming out. That would be the corona. Or maybe this picture here, like this kind of gray, blurry stuff coming off from the sun. That's the corona. And you can only see that during a solar eclipse. So when can the corona be seen? Only during a solar eclipse can the corona be seen. All right, last questions here. Match each description to a feature of the sun's atmosphere. So spectacular features of the sun's atmosphere that occur near sunspots. So these are solar flares. Actually, let's read the other ones here. No, these are prominences. I apologize. So these are big loops of fire that kind of come out near sunspots and they arc up from the surface of the sun. Number 11, the areas of gas in the atmosphere that are cooler than surrounding areas. This is what we call a sunspot. So it's an area that there's a bunch of material that's a lot cooler than stuff around it, so it gives off less light. It looks very dark, it looks black. But in reality, they're actually very bright. It's just in relation to stuff around it, they don't look that bright. So they look black, but they're really not. And then number 12, sudden releases of energy that produce X-rays and hurl charged particles into space. This is what we would call a solar flare. Is that when the sun spews off stuff into space, and it can do a lot of damage to stuff here on Earth if it gets into our atmosphere, because they're very highly charged particles and they mess with a lot of the electronics and power lines and stuff that we have on Earth, as well as our satellites and stuff that are in space. So, all right, so those are all the questions. Hopefully that helps you, and if you have any more questions, you can always ask, but otherwise I will see you in the next video.